Hey there, folks. This is Duane and only Duane. Welcome to Math on the Rocks. If you're listening to this, so there's a bunch of ways you can listen to our podcast, right? You can download it from iTunes. You can, or like that Apple thingy thing. You can listen to it on Spotify, but you can also watch it on YouTube. And if you're careful, you can watch it on Spotify. So we got a bunch of different ways for you to access our podcast. Please pick one of those, whatever works. Today, because what we're going to do is we're going to replay a webinar that we recently hosted, the California Math Council Central Region. We hosted a webinar recently with the great Albert Vilalta. And so you may want to watch it, but it's not necessary. You don't have to. So here's the deal. Albert, so when we talk about what does math education look like, what should it look like? What is our vision for math education? Good, equitable, awesome math education. If you ask 50 different math teachers, you're probably going to get 50 different answers. All right. And so one of the awesome things about the new California math framework is in chapter 2, it lists the 5 components of instructional design that encourage equitable outcomes and active student engagement. Basically, it's saying, hey, you want a vision for what good math instruction looks like? Here's 5 things you need to do. And it's take it or leave it. I mean, whether you agree with it or don't, what I love about it is the California framework is like they're like planting a flag in the ground and saying, here we are, this is what we believe in. And I tell you, I think these 5 things are aspirational. It's also doable. It's attainable. And the 5 things: 1, teaching big ideas. Instead of teaching a bunch of minute little skills that feel like they're disconnected, teach big connected ideas using, number 2, open tasks. So open tasks might be an open middle, where the kids can access the problem in a variety of different ways. It might be open-ended, meaning some kids might get the answer 17, other kids might get the answer 23, and they're both correct, meaning it's open-ended. It might have open beginnings, meaning there's a variety of ways that students might initially access the task, even though they're all going to end up at the same location. So open beginning, open middle, open endings, use open tasks. Number 3, teach towards social justice. This idea of being aware that every decision we make when we're teaching is it's a cultural decision, it's a political decision, whether you like it or not. And just the haters saying 2 + 2 is 4, and saying what's political or what's debatable about that. They're just it's a red herring. That making a decision to teach everyone well and to teach meaningful math is a social justice stance. Math is a civil right that all students deserve. And so that's number 3, teaching towards social justice. Number 4, supporting students' questions and conjectures. And the idea being students are not empty vessels that we're filling knowledge in. Rather, students are supposed to be engaged in their learning, asking questions, making conjectures, and testing them out. And then number 5 is prioritizing reasoning and justification. So as the students are asking questions, tackling big ideas through open tasks, working towards social justice, making conjectures, the students are going to be the ones who are going to be working on the reasoning and the justification, of course, guided every stinking step of the way by teachers. So what I love about this webinar that you're about to listen to with Albert is he doesn't belabor these 5 points like I just did. He just does a bunch of math tasks. And through those math tasks, you get to reflect and see these 5 components just naturally occur. It's really kind of cool. So folks, enjoy this wonderful webinar.
I'm very excited to be able to turn over this conversation today to Albert Vilalta. He is joining us, everyone, from Friday. And I know that sounds weird, but that's because he's in New Zealand. And I just learned that they're 19 hours ahead of us. So he's already on Friday mode while we're still stuck in
Friday
Thursday.
morning.
Right?
Yeah.
So Albert, I'm going to go ahead and turn it over to you, sir. And we are looking forward to what you have to share today.
Great. Thank you so much, Cole. Thank you to Kern County and to the Central Valley in California for inviting me and asked to talk here. I'm trying to share my screen while I'm talking. This is part of one series that we're doing on deep conceptual understanding on the New California framework on big ideas. But I'm hearing that there's many people joining from several places beyond California. So I hope and I think it will be useful for anyone interested in algebraic thinking. We will be linking a little bit with the New California framework that is upcoming, but the relevance of this is international, and I hope you join me in this perspective. So the title of the session is Deep Conceptual Understanding on Big Ideas, and today we're talking about functions within algebraic thinking, and this is by Innovamat. I will let you know in a minute who is Innovamat, and as you all know, we're co-hosted by Cole and the California Mathematics Council, concretely the Central Valley. So, hola, who am I? My name is Albert. I am a former telecommunications engineer. I became a math teacher almost 10 years ago. But then that was in high school, so I turned my eyes into earlier stages. I became a professor at the university, trying to understand better the earlier grades before students get to high school, so elementary, and even sometimes I go into the early childhood classroom to understand better all these trajectories and how kids progress in their learning of maths. I became a researcher there, and I am a PhD candidate. I hope I finish my PhD soon enough, maybe in 2 or 3 months, I hope. And I am a math specialist at Innovamat, an author within this math organization. We develop curriculum, we develop PD, as we all are here today for, and we support districts in different countries, and lately quite a lot in the US and specifically in the West Coast. So without further ado, well, why I'm in New Zealand? It's not that I am living here or I'm on vacations. I'm in a congress here, one of the most or the biggest congress in math education, the PME. And this year is in New Zealand, very far away from you guys, but even farther from Barcelona, where I flew from, because it's literally the other side of the world. If you made a hole from Barcelona, you would end up in New Zealand. So I am very, very far away from home. Before diving into a little bit of theory and hands-on activities, I promise this session will be very hands-on. I recommend you to take pen and paper. Let's do a little game in which I will try to read your minds. As far away as I am, I will try to read your minds. So I'm asking you to, all of you, think of a number. Okay, you have it? Hope you have it. Now, add 3 to this number. Now double it. Now add 4 to the same number. Now instead of doubling it, we will halve it. And last but not least, take away the starting number. And I warned you, you should have pen and paper. Write down your answer. I think that we all can type down our final number after the 6 steps in the chat. Let's do that.
Can we give it like a 3, 2, 1, go so we can see the waterfall?
Oh, let's do that. Yes, thank you.
Ready? So
3.
Go ahead, Albert. You got it.
No, you go.
All right, ready?
This was your
3,
idea.
2, 1. Let's see a flood of responses. What did we get?
What? You're not that original. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. I see a 4.5, and then I see a 0, but most of you have 5s. Now, I understand that we are always, as we will go through the presentation, we will be playing like a role game, right? I will play the teacher, you will play the students, and then we will come back to our original roles as teachers and analyze what is going on. So now What happens here, can you imagine in a classroom, right? All the kids raising their whiteboards or their papers with a 5 and being very amazed on what did just happen, right? I said I would read your minds, and reading your minds is also like this magic that you could add to the activity. Is also another approach that you could use instead of showing the numbers. For the virtual session, I thought that writing that on the chat was better, but I could have said, "Let me read your mind. Go to you in the classroom, touch your head a little bit, and do like a little magic trick, and say, I'm thinking of a 5." And surprisingly, be right with all the kids that you try, and that works beautifully. Now, this is the role-playing game I was talking about, but now analyzing these as teachers, and you all know that if we're talking about algebra here, we will be seeing this, and you can anticipate what's going on, right? And what I love is this representation of what's going on. Let's see. All of you got a 5. Dean actually corrected at the end, made a mistake calculation. Oh, no, Melissa was making a mistake calculation. That is beautiful because you saw all the 5s and you thought that you may be wrong. So that is great. That is great mathematical and critical thinking. And we have to embrace the error and the mistake in the classroom as an opportunity to learn. And now let's focus on what is going on. I really love this visual representation of what is going on by the Enrich project from Cambridge University in the UK. They do this representation. Okay, we have a number, which is this blue stick here. We add 3, so we have the number plus 3. Then we double it. As you can see, we have twice the blue part and then 6, 3 plus 3. Then we add 4. Then we halve it. And then we remove the original blue part, the original blue segment, you see? Now, it doesn't matter what was your blue segment, all of you will get a 5. And I find this visual representation a wonderful way of seeing what was going on and why this magic trick works. By the way, if you do this in the class, I am warning you that the first time I did it, and I'm terrible at this, you will see maybe today, I'm terrible at ending the class. That is one of my weaknesses, right? I always want to say more, and the time is up, and I am like literally speaking over the alarm, over the kids wanting to go to the playground, etc. Right? So first time I did this kind of activities, all the kids left thinking that indeed I was a magic, right? It was a magic trick. And that is wrong from a mathematical perspective. We don't want kids to think that math is magic, because magic means, okay, magic is wonderful and is maybe engaging, but it has a component that is far away from math, in which we don't know why things happen. And that's the key of magic, right? Here, it is not magic. It works, and it always works, and that's how math are, right? So it's very important that if you do this kind of activities with your kids, you devote some time at the end to at least discuss why this worked and to give the impression that this was not magic, okay? You can, exactly, Cole, demystifying the math. The math is not an opaque thing, it's not a black box in which you cannot see what's inside. No, math is accessible, and we can all understand through, in this case, a visual representation of the algebraic thinking that was here, right? And now these kind of activities are wonderful also for kids to go home with some of these ideas and try and do mental math while doing these tricks to their parents. So we have a win-win here. While developing algebraic thinking, we are also fostering the number sense and fluency. But this was just to break the ice. Let's see what we're going to do today. I'm going to do real fast an overview of our shared vision of math education, and I hope it's a shared vision among all of us here. And then I will go into some examples, as I was saying before, to unveil the functions within the algebraic thinking branch of mathematics. And at the end, we will have a few minutes for conclusions, if I am fast enough. So let's go to part 1, to our shared vision of math education. By the way, just in case I was not clear enough, please, if you have any question, don't wait until the end. Let's do this informally. If you have a question, you can write it on the chat or even open your microphone so you feel comfortable and just interrupt and have the conversation. That's how I would like it to be. Virtual sessions made this more difficult, but it's even more important then. Now, our shared vision. This is from the California framework, but I am sure that no matter where you come from or where you're reading this from, you will be pretty much comfortable and aligned with this framework, maybe with different words, but at the end, this is how we understand math education in the 21st century. And I really like how the California New Framework emphasized three aspects of math education. The whys, the DI are the drivers of investigation, right? So understand and explain, predict and affect are the drivers of investigation. Is the why are we doing what we do in the classroom? This needs to be like a North Star for us as teachers. Then we have the how, in the left part of the screen, in which we have the mathematical practices by the NCTM. We could have the processes back in the days, the 5 processes: problem solving, reasoning and proving, or reasoning and argumentation, then communication, then representation, connections. Nowadays, in the US, we have a framework in which we go deeper into 8 mathematical practices. And this is the how we do and learn math, right? It's like that we give meaning to the content. The content enough, which is the green part, by the way, the content by itself is not enough. The content needs to have meaning and needs to be applicable into our thinking strategies. That is the how. But don't get me wrong, without the content, there is no math. So both sides of the equation are important. The hows, the processes, the mathematical practices are key, but don't forget the connections and the contents that give the structure to math. And the new framework goes through 4 big clusters of content, which emphasize these connections. And they are reasoning with data, exploring changing quantities, which, by the way, spoiler alert, will be very close to what we do today, algebra. Taking wholes apart, putting parts together, which opens the door to all the fractions world and rational numbers, and then discovering shapes and shape and space, which is geometry, right? So this framework, these 3 parts are really navigating and helping me when I design an activity, or when I implement an activity, or when I model, when I coach. This really helps me. And I'm thankful that the California framework puts words to it, but I'm sure that is our way of understanding math these days for all of us. I also want to emphasize real quick this quote from the chapter 2 of the framework. I really like how they define the 5 components of instructional design, right? For equitable outcomes and student engagement, probably the 2 biggest challenges that we are dealing with these days, right? And they propose 5 components that I really love. 1, teaching big ideas. And by big ideas, we mean big clusters or groups of related content that need to be connected. Number 2, use open tasks, rich tasks, tasks in which the thinking is the main character. Number 3, teach towards social justice. This needs to be, and every day it's more and more important, and it needs to be at the center of the debate. Teach towards equitable outcomes, social justice, and attending differentiated instruction. Number 4, support students' questions. It's not that I am talking all the time. That's why I asked you to ask questions as much as you want. We want to support students' questions, embrace them, even if they sound silly. No, they are great. Any question is welcome, right? And then conjectures. What if? What will happen if? I think, I predict this, and then we check. This is the core of mathematical thinking, much more than just doing calculations of numbers. And number 5, reasoning and justification, which is pretty much aligned also with the mathematical practices that we were saying a minute ago. Okay, that was a quick introduction. If you want more help or having a partner in crime to discuss the nuances of the mathematical framework in California, I'll be happy. At the end, you will have our contact, and I'll be happy to have a further conversation, go deeper into the documents, and discuss more of how we interpret what the framework says to us. But I think that with these couple of ideas, now we have an overview, and I hope, and you're free to say the opposite, please don't feel the pressure. I hope that we are all on the same page, and this is how we imagine math education. Or at least, and it's not that you should be doing all of it perfectly in your class today or tomorrow or September 1st. No, I'm not saying that. But at least this is your vision on how it would be. Then all of us have days in which we go in more like traditional teacher-centered approaches. That is okay. You don't have to feel bad about that. But at least you need to have the idea of, okay, this is my North Star. I want to go there, and I'll be working and learning towards this direction. And I think that being here today in summer vacations for you in July, and I mean, what can I say, right? This is the best of the intentions. You are people who is committed to math education, and therefore I think that we are all aligned. Now let's go to part 2, in which we will be working with activities. What is algebraic thinking? When you think of algebra, algebra is all over the place. Everybody is saying that algebra in high school is one of the biggest concerns. Kids are not understanding it. Okay, but what is algebra? What is algebraic thinking? Okay, Jessica says, taking the concrete form to an abstract representation. I love that. So generalizing, right? So see how things apply in further cases. Search for rules, patterns. Yes. Finding patterns, again, and understanding change. I love that. Understanding change is key in early stages. Seeing structure, finding patterns and structure, numbers that are not known. Great, Charlotte, beautiful. Technique to simplify the life situations into mathematical terms to find solutions. Indeed. Patterns and structure to make sense. I love that also, make sense of a situation. I think you see that there's a trend in all your answers, right? Let's see what the experts say. What does research say? I'm quoting here Kathy Thiele, the former president of the NCTM, the National Council of Teachers of Math in the US and Canada. And she says, algebraic thinking includes recognizing, and here we will see most of your words, and analyzing patterns, studying and representing relationships, making generalizations, which was also in your answers, analyzing how things change. You see how I underlined or I bolded the words that I found more important here, and they are very much aligned with your answers. That is great. It means that we all understand algebra in a similar way, which is key to be all aligned. Then, of course, facility in using algebraic symbols, which typically, okay, I'm gonna here unveil a little bit Kathy's thinking here. She says, of course, facility in using algebraic symbols is an integral part of becoming proficient in algebra. Yes, but here is the key. But trying to understand abstract symbolism without a foundation in thinking algebraically is likely to lead to frustration, right? Algebraic thinking can begin when students begin learning math. This is key because when we think of algebra, and that's why I said, hey, think of algebraic thinking and not in algebra in general terms, because algebraic thinking goes beyond algebra. It's the foundation and includes also algebra, of course, but it includes more things, patterns, change, all these words that you were beautifully quoting. So we have to go beyond solve this equation or graph this function, right? And actually, the problem that in the US is experiencing with algebra is experienced all over the world. Kids in my university classes, the first day I have 80 students, and the first day they are pre-service teachers. I always ask this question. Why are you studying this? Do you like math? I ask this kind of questions, right? And what's your story, your math identity? And I would say, and I don't have a formal study on this, but I would say that 80% of my students, so maybe 60 people, 50 people, 60, 70 people, say that they liked math until algebra came into the equation. The day algebra came into the equation, never better said, they stopped liking math. And they don't say it this way. They typically say the day when numbers became letters, that is the day I stopped loving math. With numbers, everything was okay. But with letters, I don't understand anything. And that is precisely the key. And they don't understand, generally speaking, they don't understand anything because numbers are concrete and algebra is about generalization. It's about going beyond specific cases and see tendencies and see change. And that is precisely a shift in the mindset that is very difficult for most of our students. Another definition, I promise this is the last one, and then we will go to the examples through the framework. Algebraic thinking, I'm quoting here Kieran, one of the best authors when it comes to algebraic thinking. I am in a congress, as I told you, and Kieran, in all the talks about algebraic thinking, Kieran is always quoted. Kieran and colleagues says, algebraic thinking in the early grades involves the development of ways of thinking within activities for which letter symbolic algebra can be used as a tool, but which are not exclusive to algebra and which could be engaged in without using any letter symbolic algebra at all, such as relationships, structure, change, generalization, problem-solving, modeling, justifying, proving, predicting. You see how this is very much aligned with the mathematical practices as well, right? So this is an opportunity for us as educators to think beyond algebra in high school. Now I go deeply into the framework in California, right? In the Big Ideas framework, there's this quote: in grade levels 3 through 5, students advance their algebraic thinking as they understand properties of multiplication and relationship between multiplication and division, and use the 4 operations to solve problems with whole numbers. And the focus here is in how algebra affects our understanding of numbers and operations, or probably the other way around, how understanding deeply the operations enhances our algebraic thinking as well, right? And this is a connection that I always make at this point. Let me share a personal story here. Typically, right, with the students I found, and this year it happened to me, right? When students tell to you or say to you, or even parents, think of a parent, these parents that come to your parent family nights and complain about this way of teaching math in which there's more things about learning the operations beyond the algorithm. No, I was in a family night last year in the US, and one parent came to me and said, all these strategies, jumping on the number line, all this is great, but why not just stick with the algorithm? The algorithm is enough. The algorithm works always, and it's enough. And here, this is this vision in which, okay, the algorithm is enough, but what is the goal? If the goal is to calculate, you better use a calculator. If the goal is to think, if the goal is to learn and develop number sense, then the algorithm is clearly not enough. And I put this parent an example. I asked him to subtract 1001 minus 997, and he goes, it's 4. And I said, can I see where you did your algorithm? And he said, no, I did not use the algorithm. And I said, oh, but I thought that you said that the algorithm was the only strategy and that was always the solution. And he said, no, well, depends on the case. Precisely. The algorithm is respectable and it needs to be taught and developed in the classrooms, but not only the algorithm. And beyond that, and related to algebra, if you deeply understand the algorithm, and that comes with deeper number sense and understanding of how this relationship between operations are, if you deeply understand that, then the day in high school in which the teacher says, okay, today we're going to multiply polynomials, or we're going to divide polynomials, if you deeply understood the algorithms and you deeply understood and developed number sense, it is just an easy transition. But the reality is that it is not an easy transition. It is a terrible transition for most of our students. Transitioning from arithmetics to algebra is dramatic for most of them because they did not understand the algorithm, right? But today is not about the algorithm. This gave me the opportunity, thanks to the framework, to talk about it. But today is about algebraic thinking. Since I'll be sharing or will be sharing these slides with you, no need to focus here. But here you have some places within the big ideas in the California framework in which you open the door to algebraic thinking. Look for patterns, express regularity, create patterns, look for patterns, explore changing quantities, as you see. That was TK's second. I'm sorry to go back and forth. And now here is another slide with 3rd to 5th grade. This is much before high school algebra, formal algebra. This is represent data, patterns in 4 operations, telling a data story, plotting patterns. All these ideas open the door to talk about algebra. And that's what we are going to do. Last theoretical slide, I promise. This is the 4 stages for algebraic thinking. That it's a simplification of the theory and the research behind it. But I think it's useful for you to have this picture, right? We have 3 stages, 4, because there's a stage 0. And don't get me wrong, this is not sequential. It's not that you have to master stage 0 before moving to stage 1. No. Of course, every stage is a little more complex than the one before. But this is not unit 1, unit 2. No, this is a spiral in which we go back and forth, back and forth, back and forth, right? Stage 0 is recognizing, and this is kindergarten, recognizing attributes and relationships. First, between shapes, between simple numbers. And later on, in high school, we will develop relationship between variables. Stage 1 is understanding change and pattern. You cannot understand what is a pattern, which is a repeated rule, if you don't understand change itself. And to understand change in stage 1, you need to understand what is changing, and that is stage 0. You see how it builds upon each other, right? If you understand the attributes and relationship in stage 0, you can then understand what attributes are changing, and that's stage 1. And then we go to more formal and closer to algebra itself in stage 2 and 3, with conditions, aka equations in high school, and modeling or functions, right? And it's not that, again, you don't have to master everything about equations before moving to function, as we will see today through the examples on functions. And then the typical difficulties, the arithmetic habits, as I was saying, the symbolism is very hard for students, the vocabulary, variable, range, domain, all this vocabulary on algebra is hard to master. And then this was one of the first interventions today. I think it was Melissa, right? And if it was, no, it was Jessica. Jessica said, taking the concrete form to abstract representation. Yeah, and that is precisely one of the biggest difficulties in algebra. Understanding that things are in general, right? That when you write x equal whatever, you're not talking about a specific value, but more of a function or an equation. Okay, we have a framework. Now let's go into stage 3, aka functions, and we dive into it through some examples. Let me show you this example. This example can be for TK, K, first grade, even second grade if your kids don't know it. This is a beautiful activity on changing boxes. You probably know them, but let's explore. For instance, the first one, right? There's a square that is small and red. I tell you it's small, you don't know it because you don't have a reference, but this is one of the logic blocks that you have physically, like manipulatives. You put it into a box, the card tells you what is going to change, and my question is, what is the answer? What is the exit, right? What is the output? So if the change is in color, the output could be either a yellow little square or a blue little square. And you see how I emphasize little and square? Because those are the attributes from stage 0 that I was telling you that kids need to recognize before analyzing what is changing, you see? And now a thing that you can see, and all these boxes work the same way, is that it is key that within the same activity or in different activities that you do with your kids in TK first grade, you change the position of the question mark. You should not always ask for the output. Sometimes you would ask for what is the change, as in the second example here, the one in the top middle, right? It is a yellow little square that is going in and a red little square that is going out. What was the change? What is the box doing? Or sometimes you give the answer, the output, and the change, and I ask you what was the input, as you can see in the middle bottom example, right? It is important to move the question mark all the times. Anytime you design an activity or you ask questions to your kids, try to move around the question mark. Where are you placing the focus and the question? In this way, you foster this critical thinking. Okay, this activity was more of me explaining it than you doing it. It was too easy for you probably. So let's move on to a similar one. Here you have a box. And I know Cole knows this box, so please, Cole, don't spoil it. So there's a box that it's closed. We don't know what's going on in this box, right? But I want, and I'm sorry that I now will be picking one of you guys. Hannah, can you give me a number? Type any number you want in the chat, and I will give you the answer. Okay, you give me 4. Okay, the box is doing its thing. That's my head. And my answer is yes. That's all I can say. The answer to 4 is yes. Okay, let's see. Melissa, can you provide a number? 3. 3 is a no. Oh, we have 2 Melissas. Great. 7. 7 is a no again. Oh, Melissa thinks she knows the rule. That is great. In the class, you should not ask now Melissa, okay, Melissa, what's the rule? Because that, if Melissa is right, which probably is, it kills everything else. Instead of that, we will play reverse. Now, Melissa, I am going to give you a number and you will say yes or no. In that sense, I will have more evidences. Give me, no, I give you a number. Now, Melissa, I give you number 10. 10 is a yes. Okay, great. Okay, I think Melissa, both Melissas, I think they know. Okay, but now you see how and this is again the role-playing game. It is a management skill here, right? A management practice. Try to manage the activity in a way that you don't kill it too early for most of the kids, right? And now we could explore more and more numbers as we have more and more evidences. This activity could last beautifully 10, 15 minutes with kids in any grade, and you can change the rule in the box to match the content and the operations that you wanna practice with your kids depending on your stage, right? But since I want to show you more activities, I'm gonna reveal oh, I love that. What about a third? A third is the answer is no, as you probably know, right? Yeah, and that would open the door to fractions, right? And if you do this activity in fourth, fifth grade, you probably some kids will try fractions. And of course, you can do a box in which the answer or the rule is about fractions. But this box, I have to reveal it already. This box, as I think Melis wrote on the chat, the question was, is it even? So any number that you gave me, my answer was yes or no, depending on if the number was even or odd, right? A different alternative, instead of even, if you are in a later grade, you can ask, is it a multiple of 2? And it's the same answer. There's the same rule, right? But maybe the concept of multiple of 2 related to being even is a good connection that we can foster for kids to understand that being multiple of 2 is the same or is equivalent as being even. And there's even a third way of saying the same. Is it divisible by 2? So depending on what's your focus, you can change the rule. And even within a rule, you can word it different ways depending on what's your interest and what's the vocabulary that you want to foster, right? And here the rule was yes or no. Sometimes the rule is giving you back the number +1, the number +2, half of the number, whatever you want, right? And this is the evolution of the boxes from kinder and first grade with the geometry shapes, right? You see how this activity works. And it's beautiful how kids then invent their own boxes and play and try to guess. And I found some of my kids last year, not the year before in Barcelona, some of the kids that I was helping modeling and coaching, where I visited them a few weeks in a row, which doesn't happen to me that often anymore, sadly. And they were, after a while, after doing this activity, let's say week 1, week 3 or week 4, I visited, and they were sometimes playing to this game. Like, I'm thinking of a box, and the other kid was trying like to have these conversations between children without the teacher posing them. That is magical, and it does not happen always, I want to confess. But when it happens, it's great, right? I have another rule here. We have these numbers, but think, since we already covered pretty much these rule boxes changes, I think I will give you this as a challenge, and you can think about it. And if you find the answer, you can send it to me through the email that I will be sharing at the end. And therefore, we have like a little homework divertimento for vacations for you to think about while you are enjoying the beautiful Californian sun, if you are in California, or the beautiful weather wherever you are in this summer, right? So I will leave it here. The thing is, you have these numbers. They are transformed by the same blue arrow rule. It's the same in any of these numbers, and they get transformed, some of them, as you can see, 4 into 4, 6 into 6. That seems like a very lazy transformation. But then 1 into 2 and 2 into 5. What is going on? I don't want the answer. I am not asking. Just think about it, okay? Now, we've been talking about these boxes. How is this related to functions? I assume you're seeing where we're going, right? But functions, and I don't want to go deeper into like the theory here, but functions essentially can be expressed in 4 different ways. Number 1, with a sentence. In this case, @2. @2 is a function. Another way of expressing functions is with a table of values. You have inputs and outputs, and here, clearly, the function is @2. We wouldn't need the middle column if we had both green and yellow columns. We wouldn't need the @2 column in the middle, because we would have the same idea of a function, right? So way number 1 with a sentence. Way number 2 of expressing a function with a table of values. Way number 3, as you can see on the right, the graph, plotting. And here, as you can see that we put a lot of attention in how we design activities at Innovamat. Here you can see the yellow column is matching the yellow vertical axis. because kids have a hard time knowing, at least the first days when they deal with graphing, knowing what is the x-axis and what is the y-axis, what is the vertical, what's the horizontal. So here you can see how we try to bridge this difficulty by using different colors, right? So here the only thing that we need to do is, okay, number 2 in green matches number 4 in yellow. Number 5 in green matches number 7 in yellow, and so on. And we could even draw a line and link all these dots, because if we had 1.5, we know that the answer would be 3.5. So it makes sense joining these dots, right? Because the values in between, if we go to beyond natural numbers, if we go to fractions or we go to decimal numbers, it makes sense. The rule still works. You can take 2.7, add 2, 3.7, and that's why we can join the dots. That is not always possible. When it's a continuous function, then we can join them. But I don't want to go to deeper concepts of analysis. So here we have the fourth and last way of expressing a function, through the algebraic expression that should not whatsoever come into your lessons unless you are in high school. There is no need. You have 3 other ways of talking about functions and settle down this idea of change without using the complex of an expression such as f of x equals x plus 2. But it's the same idea in different ways. And you see now how the boxes and the understanding of change and the understanding of attributes and qualities are building up until we reach this very moment? I hope you do. So now we will finish with one last example, one last activity. I don't know if you know Kurt Vonnegut. He's a great novelist, author. I really love his writing. And he has a video. Actually, this is a link. I am not now sharing the video with you. We don't have time. It's a 4 or 5 minutes video. It's on YouTube, open. So you can see how he explains the different types of stories that can be drawn, or well, his focus is not on math. His focus is on storytelling and how stories are built in Shakespearean literature, in modern literature, etc. But it's a 3-4 minute video in which he explains that there are only a limited amount of different stories, and he plots the stories to explain to the audience what he means. And I found that really powerful. So why don't we use this, right? Now, I am sharing with you 3 graphs. The vertical axis is the fortune of the main character of the story. The horizontal axis is the timeline, okay? Now, this is very difficult. I don't expect you to guess right? But let's think, what story is this graph telling? 3 popular stories in the American literature. Well, not only American literature, beyond universal literature, but well known for American audience. I made sure that that's the case. We have 3 stories. It's almost impossible to see, but what we can at least start seeing here, the first graph, we see that we start in a more or less okay position. We go down, then suddenly we go up to the skies. We are very, very happy that the character has a lot of good fortune, or is experiencing happiness. Then we go straight down to hell and then back to heaven. And the story finishes with the character having a peak in the happiness the character is experiencing. While in number 2, not so good. We're going up and down, up and down, up and down, and the ending is terrible, right? Probably is not a tale for kids. And now number 3, it's similar to number 1, but in this going up and down, the second time, the character does not go as down as in number 1. I don't know if you have guessed what is going on here. Anyone wants to guess? We have 5 last minutes, and I have 1 more or 2 more slides. So if anyone wants to guess in the chat, is this any story that is matching? And maybe it's not the story that I wanted, but probably there are more stories that match these graphs, as Kurt Vonnegut explains in his talk. Any guesses? No? I can give you the 3 stories that I'm thinking about, and then you decide. Yeah, storybooks you read at night, yes. Fictional stories, yes. Popular, well-known stories, such as, for instance, Goldilocks and the 3 Bears, for instance, which is not any of these. 3 is kind of like Shrek. I completely agree. Shrek follows this path. It's not Shrek in my description, but it is definitely Shrek. Shrek 1, yes. Little Red Riding Hood. Oh, Charlotte, yesterday while I was preparing these graphs, I added Little Red Riding Hood, but the problem was that I found several different versions. In some versions, the guy, I don't have the word in English for that. The lumber, the lumber, the one that chops trees. Yes, the lumberjack. Thank you, Charlotte. The lumberjack arrives and saves the day, and in some versions, the wolf wins. It's Little Red Riding Hood, and that's the end. So I had several different interpretations of the story. Right. Yes, this is great, Susie. Exactly. I really love literature and I really love math. So this activity is great. Now let me tell you. One of them is Romeo and Juliet. What can you expect? It's going to end bad. It's the second graph for sure. Yes. 2 for sure. Yeah, because they kill each other. Well, they kill themselves at the end. Love is not possible. And we all know how it ends. It's Shakespeare. What can we do? Another one. So we know that number 2 is Romeo and Juliet. Shakespeare. Cole, I agree. Yeah, depending on if you interpret the ending as good or bad. But since I am talking about fortune for the characters, I would say that you remember in Romeo and Juliet when they kill themselves, it's a confusion. It's terrible. That moment, it's terrible because Juliet thinks that Romeo is dead and then kills herself, but then Romeo was not dead. Romeo wakes up and sees that Juliet is dead, and so it's like a never-ending going down to hell, right? Number 2 is Romeo and Juliet. What is number 1 and number 3? I'll tell you 2, and you have to match, which are very difficult, very similar. So it's difficult. One of them is Cinderella, and one of them is Jack and the Magic Beans. I don't know if that's the name in English, but you know what I mean, right? Jack and the Beans. And they all look like House of Game of Thrones, yeah, House of Cards, or yeah, the Beanstalk. Yeah, thank you, Jack and the Beanstalk. One is Jack, and therefore 3 is Cinderella. This is hard, and I know because the 2 differences between the chart is the beginning, in which one of them is on the bright side and the other not, and the ending. Let me show you the answer. Number 1 was Cinderella, number 2 is Romeo and Juliet, and number 3 is Jack and the Beanstalk. This is my interpretation of the story. I plotted them, I give it values. Of course, this could be improved and discussed. You can see all these little parts of the story, but since we don't have that much time, I think we can see it here, right? Now, if you don't want to go to literature, but I think it's great, but sometimes depending on the time you have, or depending on the background here, this activity was possible because all of us knew the 3 stories. But if you're doing this in a classroom that is, for instance, in let's say in 2nd grade, it's very hard that they know all these stories, all their background. So you can do these kind of activities in which it's the same idea, but with the stories are like shorter cases, right? For instance, number 1, the more cherries you pick, says the more expensive the purchase will be. What is that? A, B, C, or D? Number 2, when you take a taxi, you pay a fixed price to start the journey, plus a price proportional to the distance you travel. Which one is that, right? And number 3, the rocket started to climb faster and faster until it disappeared from sight. And now you might see, I won't give you the answers. And actually, it's okay that you try, but to guess, I am not giving you the answer. I'm leaving it. The activity, I'm leaving the activity here. It's not that relevant to know the answer. Well, you can see that the taxi probably C. We could have a great conversation if we were in a real setting of a classroom, right? The key thing here is that I have 3 stories and 4 graphs, which number 1 fosters critical thinking in, okay, one of them is not matching. One of the graphs is not matching any story because I have more graphs than stories, that's for sure. But then it opens the door, which I invite you to do with your kids. It opens the door to, okay, what is the graph that is not matching any story? Let's say it's B. Okay, can you make your own story for B? Invent your own story, create your own sentence that is B, right? And then you could extend this activity with labeling the axis, which is also an important skill in math, the more higher you go in, the higher you go in the grades, the more formal you have to do to be with these things. But in early stages, it is great to just open the door to tell stories through graphs. This is going to dramatically help your kids understand functions when they arrive into algebra in high school. Okay, and I'll finish with this, and I'll hand it to Cole to finish. This is my graph. Graphs also can explain personal stories, right? This graph is representing my math identity, which is I use this to introduce myself to my students at the university the first day, and I ask them to draw their graphs, and then I devote 2 hours to go one by one while they'll solve other problems. I go one by one for them to explain me your graph, and tell me who you are related to math. And that I've been doing this for the past 2 years. It is wonderful. The students open themselves. Of course, it probably requires kids that are old enough to reflect on their own learning and on their own path. You cannot probably do this in first or second grade. But I just wanted to highlight how graphs can explain personal stories. And it is great to show yours, to open yourself to your kids and say, hey, I've been on the dark side of math identity sometimes, right? And what questions do you have about this? I typically show this and I tell the students, can you post questions that you have? And so they start asking, why was it up and then suddenly went down? Okay, and then I ask, what part of the graph you're referring to? So we can have a discussion on graphs and on math identity, right? Here, well, it's a very easily summarized of my story. It was all okay, primary, high school, everything okay. I was good at math, right? But then I arrived to the university. I understood that I was not taught math in elementary and high school, that math was not what I expected. And it went down to hell. I was desperate. I was failing some subjects in math in my engineer degree, but then eventually I decided to become a math teacher, math education researcher and professor, and I'm now in the green zone, right? This can explain stories. You can explain your weekend. You can explain whatever. It's not necessary to go this philosophical with this kind of activities. I hope you find them useful. As a conclusion, I'm not fan that much of conclusion. I think the conclusions were as we were doing the activity, but I wanted to outline again these 5 components of instructional design that encourage this engagement and equity. There's no need to read them again. I think that what we did today covers most of them, or opens the door to cover most of them. And of course, you can ask questions. I hope you enjoyed it. Here, you can get the slides. You can share feedback. I hope you find the solution for the exercise we left with the blue arrows. The solution is in the slides. So please, if you tackle the activity, don't check before you solve it. Don't cheat. And you have my email here if you want to debrief, if you have any feedback, constructive feedback, or you have any question or any comment, I'll be happy to hear you and work with you. Thank you all. Cole, floor is yours.
Fantastic. And thank you, Albert. Like 5 slides ago, I said, I'm going to steal that idea when you were telling me, connecting all the fictional stories. And I'm like, that's a wonderful idea. And then you showed me the identity graph. I said, well, I'm going to steal that too. So just know if you see that out and about, probably within the next couple hours, I'm sorry. But I already seeing uses for those things. Absolutely. Well, thank you, Albert, so much for your time. Thank you for joining us from New Zealand. I know you are busy over there researching, getting ready to jump on a plane, but we appreciate you for making time for us. In closing, I just want to thank all of you that joined us today from all over. We had some guests from Canada, from the East Coast. I know we have some friends from Spain joining us as well. I just want to make sure that I send out this. Please join us as we continue our Inspiring Math Minds series. Our next session will be the 3rd Thursday in August, 4 to 5 p.m. And we will be joined by the great Annie Fetter. Will be joining us in August. So please make sure you are signing up for that. If you're on our mailing list already, you will be reminded about that coming up. Again, it is free, so pass it along to your friends. And also, we'd like to invite you to join us beyond, and we're going to get Albert on a podcast soon, he promised me, beyond our webinar, Math on the Rock. So a CMC webinar, podcast series hosted by Duane, Scott, and myself. And we're talking about all the rocky topics in California mathematics. So we hope to see you there as well. Thank you for your time today. And we hope to see you at our next CMC virtual learning series. Have a great day, everybody.